we will try to see where do we use this DC transmission, or of course say when I say DC transmission, it is assumed that there is one place at which there is excess power and it has to be transmitted to another place where there is deficit of power, and these two places are separated by some distance, say a few hundred kilometers. So, then we say transmission. Now, many a times we may be using these DC converters, I mean that is the converters that we have studied, even when there is no transmission. Okay. So, applications of DC transmission lines or just lines, links or links. Now, what is a link? A link means there is a converter which acts as a rectifier, there is a converter which acts as an inverter, but there is no transmission link. That means they are just connected, I mean they are in the same place, they are in the same place and the DC sides are connected. So, we call such arrangement as a link. Please note, if there are two converters, one acting as a rectifier, another acting as an inverter without a transmission line, that means they are close by, they are in the same building, say, or the same place, then we say that that is a DC link. If there is a transmission line, then it is called a DC transmission. Yeah, see, one of the primary reasons for choosing anything is cost. Okay. So, at some point DC becomes economical. So, if I have long distance bulk transmission, so long distance bulk power, see bulk power means a large amount of power. Then DC is economical. Underground or underwater transmission. Sometimes one can show that DC is economical also. I mean, I will get into more details towards the end of this course. And the other reason is cables have large values of capacitance. So, how does this affect the choice of AC or DC? As I said, capacitance or inductance does not affect steady state in as far as DC is concerned, but capacitance can cause problems when operated with AC. Okay. And the last application is asynchronous interconnection. Of AC systems. So, I have two AC systems, I can do what is known as an asynchronous interconnection, and I mean what does this term suggest? Asynchronous interconnection, different frequencies. So, one can say that these AC systems are operating at different frequencies. Now, most of the time when we say different frequency, what we mean is different nominal frequency. That means, suppose I have a system 50 hertz and I have another system 60 hertz. I want to interconnect. This is one way of doing interconnection. We call that as asynchronous. So, different nominal frequencies actually means different rated frequencies. Now, many a times the frequencies are same as far as the nominal value is concerned, but the actual values may be different. Now, it's many a times it's easier to operate the individual systems at different frequencies because control is different. See, control is actually done by, I mean, what control? I mean, who will control the frequency? Generator. There is a governor. There is a governor. So, the primary control is governor. Okay, where independent control independent control of systems is desired. Now, in the process this will have some advantage also. So, suppose there is some disturbance in one AC system and the other system is actually connected to this original system by a DC link. It is possible that the disturbance is not propagated to the other system. If you have a DC link, it acts as a filter for the propagation of the disturbance. Say disturbance can be in the form of oscillations. Say at some location there is a fault and the fault is cleared, then you will have oscillations. You would have studied stability, right? You would have studied stability of a single machine infinite bus. So, such type of disturbances can easily propagate to the entire system, but in the case of a DC link between two AC systems, a disturbance originated in one system will not actually propagate to the other system, though there is an interconnection in the form of a DC link. Okay. So, this has another advantage, propagation of disturbance from one system to another is minimized. Okay. Now, when you look at these are the applications, when you look at the application 1 or application 2, there is a transmission line, whereas when it comes to application 3, many a times we do not need a line. I just want to somehow interconnect. So, I have 2 points close together. When we want to interconnect two systems and you have two nearby points, we can just as well have a link, we do not need a line. So, in application number 3, this link comes into picture. Okay. So, DC link can come into picture in the case of application 3.